In this extra section, I want to dive into authentication. I want to explore how we can add user authentication, sign up and sign in and log out to a Next.js application. In my React course, React the Complete Guide, I do show how to implement authentication with React apps. And generally, since a Next app is still a React app, it works as shown there in case you followed that module. But in case you didn't, in this module, I will also explain again how authentication works, and I will show how Next.js specifically can help us with it. We are going to learn how authentication works in a Next.js application. We are then also, of course, going to implement authentication. We are going to implement user sign up and log in. And we are going to control page access to make sure that only authenticated users can reach certain pages and can perform certain actions. Now, for this course section, I prepared another starting project for you, which you find attached, which you can download, run npm install, and start the dev server with npm run dev. And you will see something like this. That's the demo page which I prepared. Here we got the starting page, a login page, a profile page, and a logout button. At the moment, the logout button doesn't do anything, and these forms here also don't do anything. We are going to add some life to this application throughout this module. And we are going to make sure that, for example, only authenticated users can go to profile. And the login page, on the other hand, should not be accessible if you are authenticated. You should not even see that menu option in that case. So these are the various things we're going to do in this section, and definitely feel free to explore the different components I'm providing to you here. It's all pretty straightforward, just a couple of forms, a couple of standard components. On the auth form, I have some state for switching between login and sign up when we click this button at the bottom. And all I do here is toggle this is login state and then use it to output content conditionally when that bottom button is clicked. So fairly standard, nothing Next.js specific here, and therefore let's now understand how authentication works before we then start implementing it. So how does authentication work? In general, and then also specifically in React and Next.js applications. The core idea is always the same. We have our client, so our browser and the user visiting our page through that browser, and our server serving that page. The server also is connected to a database where, for example, all our registered users are stored. Now let's assume a user did already create an account, and now that same user visits our page and wants to log in. How does that work? Well, the user enters some data into a login form, like this form here, for example, in the login mode. So the user enters some data here and clicks log in. When that happens, we send a request with JavaScript to the server. A request which contains the user data, email and password, for example. Then on the server, we can validate that input. We can reach out to our database and see if we find an account for that email address, and if the entered password matches the password we find in the database. And then we send back a response which basically says, yes, your credentials were correct, you are authenticated, or which declines the authentication request. And then once we send back that yes or no response, though it's a bit more than that, as you will see in a second, but once we send back that response, the client can thereafter also reach protected routes and send requests to other endpoints on our server, to other URLs on our server that might require authentication. Like, for example, that profile page. We're only able to reach it once we are authenticated, and we also only can change the password if we are. So if that request is sent to some backend API that the old password should be replaced with a new one, that kind of request should only be allowed and fulfilled if the user is authenticated. So that request which we send here needs some extra data attached to it, some extra data attached to the request, which in the end tells the backend that this user is authenticated. Because anyone could be sending requests to our API, and hence the request needs to carry some extra permission, which then should be verified on the server. And that permission part is important, because a simple yes or no sent back by the server to the client would not be enough, because we can, of course, always send a request to some API endpoint that requires authentication and say, hey, I'm authenticated. We can't just believe that as the author of the API. We need some proof that a user is authenticated. And therefore, authentication involves this exchange of credentials for permission, but the permission is more than just a yes or no. To be precise, we can't just save and use a simple yes, because a fake yes could be sent. We can't just tell a server that we are authenticated and then request protected data or perform protected operations. And therefore, instead, we need some proof which can't be faked. And for this, we got two main mechanisms. We got server-side sessions and authentication tokens. Now, these are two common approaches for solving this problem of unfakeable permissions. The concept of server-side sessions works such that we store some unique identifier on a server. So we generate some session ID, which is unique, and we store that on the server, for example, in a database, and we send that same identifier to the client that sent us the credentials. Then on the client, we can store that ID, that identifier, and then we can use that stored identifier to attach it to requests which we thereafter send to protected resources on the server. And then the server is always able to extract that identifier from the incoming requests, check if it stored that identifier in the database, and if it did, grant access, and if it does not, deny access. Now then, only clients which have this identifier are able to send requests. Now you might say, okay, but can't this identifier be stolen? Well, whilst it's in transit, it shouldn't be stolen because we should be using SSL for encrypting the connection anyways. And when it is stored on the client side, it is stored in a cookie typically, and that cookie can be configured such that it's not accessible through JavaScript to prevent against cross-site scripting attacks, and that it is only readable from the server when it is attached to outgoing requests. And even if it would be accessible through JavaScript, you should be protecting against cross-site scripting attacks anyways. And if you can rule out cross-site scripting attacks, your authentication permission stored in some client-side storage is pretty secure, because only you, the owner of this computer and the user of this browser, are able to view it. So you could only hack yourself. And some random dude wouldn't be able to just send a fake request to the server, because whilst you could come up with a random identifier, the server would not know that identifier. So that's the concept of server-side sessions. The other concept is about authentication tokens. It's not that far off. The idea here is that the server does not store any identifiers. Instead, the server creates and signs tokens, which in the end are just random strings, you could say. Random strings which can be unpacked to data packages. So we take various pieces of data and sign them together. More on that in a second. And then such a token is sent back to the client. The client can then save that token and again attach it to outgoing requests to tell the server that access should be granted. Now, even though the server does not store that token in a database or anywhere else, the server knows how it signed that token. And I'll come back to that in a second. So the server will be able to verify if a token was created by it or not. And therefore, again, if I just come up with some random token string and I send this to a server to get access to some protected resource, access would be denied because the server would not be able to verify my random string, because it wouldn't be a validly signed token generated by that server. Now, these are the two approaches we have. Now, when we build a single page application, which we in the end still kind of do with Next.js, then we typically work with tokens instead of sessions. And there are reasons for that. For one, pages are served directly and populated with logic without necessarily hitting the server. Of course, when working with Next.js, you can build pages which use get server-side props, and therefore there will be a request handled by the server every time that page is being served. But you will also have many pages which are pre-generated, and once the user is on your website, many pages won't be fetched from the backend at all, but instead will be loaded and generated dynamically with front-end JavaScript. Because you still have a single page application, at least for many pages that make up your website, after you initially loaded your first page. Then still, JavaScript takes over, React takes over, and handles your website. So that's important. You don't send a request for every page you visit, because you're not using get server-side props on every page. So the server doesn't see every request which you send. And therefore you load pages without the server being able to directly find out if you are authenticated or not. In addition, backend APIs which we use for single page applications are typically stateless. They don't care about the individual connected clients. They don't keep track of all the connected clients. Instead, the idea is that that API can work pretty much on its own. And it just is able to hand out permissions to clients who authenticated so that they can then later request access to protected resources. The API itself does not store any extra information about any connected clients. And since this is how we build single-page applications, the server is not involved in every request and every action that's happening on our page, because we handle that with front-end JavaScript and we have that stateless API connected to the SPA. And because of all of that, we could say that we have kind of a detached front-end and back-end combination. They do talk to each other sometimes, but not for every action that's going on the page. And because that's the case, servers don't save information about authenticated clients, and instead clients should get that standalone permission which allows them to prove that they are authenticated. And that's why we use these tokens. And here specifically, we use a concept called JSON Web Tokens. That is simply the most common form of authentication token, and it simply describes the way the token is generated, though we don't need to care about that too much, because we'll use a third-party library for generating and signing that token anyways. So as it seems, these JSON Web Tokens are important, and therefore we should take a closer look at them. We should understand how exactly JSON Web Tokens work. And in the end, a JSON Web Token is generated with three main building blocks. We got some issuer data, some data which is automatically added into a token by the server when that token is generated. That's some metadata which we typically don't set up ourselves as a developer, but which is pre-configured by the third-party packages we use for generating tokens. We can then still also add custom data to our token, for example, some information about the user. And then, very important, we also set up a secret key. We set up that key on the server. The client never gets to see that key, and that's important because if you have that key, you can create valid tokens which are accepted by the server. Hence, only the server knows that key. Then we generate a token with some third-party package by combining all these pieces together, by creating a random string that incorporates all that data and is signed by that key, and that is that JSON Web Token, a long string. The important thing here is that signing does not mean encryption. The JSON Web Token is not encrypted. You can unpack it and read the data inside of it without knowing that key. That key only proves that a given server created that token. But you can read the content of the token without knowing that key. The key, of course, will not be included in the token though, so you can't read that key, even if you unpack the token. Now, it's that token which then is stored by the client, so by the browser, and which then is attached to requests to protected resources on the server, so to protected API routes. For example, if we want to change our password, we don't just send the old and the new password, but we also include that token in the outgoing request. And that token then is validated by the server, which basically checks, okay, if I would use my signing key, which only I know, would I be able to generate this token? And if the answer is yes, the server knows that it's valid. If the answer is no, it's invalid and access is denied. So that's why we can't just generate a token without knowing the key. We can generate a token, but it would be an invalid one. And that's why this is a secure mechanism. Okay, that was a lot of talking about all of that, but that's the important theory, the foundation we need for then actually diving into authentication and implementing authentication. The great news is that we don't need to build all these things from scratch, but that instead for the token creation and validation and so on, we can rely on secure third-party packages. As I mentioned in the last lecture, we don't need to build everything from scratch. Instead, there is a package, the Next.auth package, which we can use for implementing authentication. Now, the Next.auth package makes adding authentication to your Next application super simple. And it actually supports a broad variety of authentication providers. So you can't just go with your own email and password combination. You can also easily add sign in with Google or Facebook or Apple or whatever you want with Next.auth. The documentation, of course, is the place to go. And there, if you click on authentication providers, you see a list of supported providers. And if you click on one, you'll learn how to implement authentication with that provider. So that is something you absolutely can do. Now here in this module, we will not use one of those providers though, but instead we will build it from scratch with our own email password combination stored in our own database so that we can really see the complete authentication flow in greatest detail. Now therefore, that is the package we are going to use, and hence to get started, what we'll do is we'll first of all install Next.auth. So in our project folder, I'll quit the dev server and npm install Next.auth to install this Next.auth package, Next-auth. We'll install that, and the Next.auth package has both server-side and client-side capabilities. We'll be able to use it on some API routes to verify if a user is logged in, and we'll be able to use it in our components to do the same. Because, of course, the answer to the question whether a user is logged in and authenticated is not just needed on protected resources on the server side, so in our API routes, but also in our client-side components. There, we also might want to show a different user interface based on whether a user is authenticated or not. And Next.auth will allow us to do both server-side and client-side validation. It will also help us with generating those auth tokens, those JSON Web Tokens. One thing it will not do, though, is manage user creation for us. We need to bring our own logic for this. It does support various databases, but mostly for other authentication methods. And when it comes to having our own user accounts, then we need to bring our own sign up API route and our own user verification logic. But that's exactly what we're going to build over the next lectures now and what we're going to explore there. So let's now get started with adding our own logic, because as I said, Next.auth won't do everything for us here when we roll with our own authentication system, with our own user accounts. And therefore, before we use Next.auth for anything, we will first of all have to add the logic to create users. Because Next.auth can then help us with authenticating those users and with getting the token for those users, but to create the users themselves, we need to bring our own logic. Hence, I'll bring up my dev server again, and I want to add an API route which gets input, which gets a request with an email and a password, which in the end should be sent from the login page if we are creating a new account. And then that data should be used to store that user. And I will use MongoDB again as a database for storing the user data, but you can go with any database you want. It doesn't have to be MongoDB, but MongoDB, especially when using MongoDB Atlas, is just great to use, free to get started, easy to use with JavaScript, and already hosted for us. So that's great. Hence, we'll need to add an API route and therefore this API folder in the pages folder. And in that API folder, I'll then add an auth subfolder. And in that auth subfolder, a sign up.js file. Now the file name is up to you. And in there, I'll then define my handler function, which will be responsible for creating a new user. And we should, of course, as always, export that function thereafter. Now, in here, we want to connect to the database and store the incoming user data. Hence, I will actually quit the dev server one more time and then install the MongoDB package again, as we also did before in the course already, and then restart the dev server. Because we'll need that MongoDB package to successfully connect to that database and talk to that database. We will actually also talk to that database from multiple functions here, from multiple API routes later. And therefore, to share some logic, I'll add a new folder on my root level of the project, a lib folder. We could also name it helpers, whatever you want. And in there, I'll add my db.js file. File name, of course, is up to you. And it's that file which should help me with establishing a connection and so on. So here in this db.js file, I'll import from MongoDB. And as before in the course, I'll import Mongo client, because that's the thing that helps us establish a connection. And then I'll add a function, connect to database, could be the function name, and in there we'll do what the name implies. We'll use Mongo client to call the connect method, and then here pass our connection string with which we connect to a database. Now for MongoDB, we can get that string from MongoDB Atlas with a created cluster, and therefore you should make sure that you have that cluster. We did create that earlier in the course already, so make sure that you don't skip those previous parts where we talked to MongoDB already. And once you got a cluster created, you can click on connect on your cluster, connect your application, and then it's this connection string which we need and which we are interested in. So I'll use that connection string, and here we now need to replace some pieces of data, like the username, password, and the database here. Now for username and password, I will go to database access and make sure that I have a valid password for this user here. Create a new password and update it. And then use my username. You need at least one user with read and write access created in MongoDB Atlas. And then add the password here. And then for the database name, I'll name this auth-demo, but that database name is up to you. That's now the connection string. Now connect returns a promise, and to use async await, I'll add async in front of the function and then await this connection result here, or to be precise, the connected client, which we get back as a response. Now, this could be failing, but for the moment, let's ignore that. And let's then just return that client here maybe. So that when someone calls connect to database, that someone gets this client. Now that function should be usable from outside this file, so we'll export it. And now back in the signup.js API route, here, I first of all want to call connect to database, and hence import this from that lib folder and the db file. Now I'll also turn this into an async function to use await here, and then here we get that connected client, and we can then get access to the concrete database by calling client.db like this. And now that we got access to the database, we want to create a new user and store it in some collection of that database. Because as you learned before in this course already, MongoDB works with collections of documents, where a single user would be a document and all the users would be stored together in a collection. We get access to a collection by calling the collection method onDB, and we can use any collection we want. If it doesn't exist yet, it will be created on the fly. So here we could maybe work with a users collection. Now to get the submitted user data, we should accept the request and response objects here in our API route function. You learned that API route functions give us access to the incoming request and then also to this response object to send back a response. And then we want to extract the incoming data. And actually, we maybe want to do that first, so that we only proceed as soon as we know that we have valid data. So here we then basically get our data by accessing request body. And then from there, we get our, let's say, email and password. And these key names are up to you. I will extract them from the incoming request body. We will just have to make sure that later when we submit this form, this auth form, that we actually do add email and password to the request which we send to this API route when we want to create a user. So therefore now we got that. And now that we got email and password, we definitely also want to validate it. We want to check that we don't store invalid data. So if we don't have an email, or let's say if not email includes an @ symbol, or if we don't have a password, or if password trimmed for whitespace has a length that is, let's say, smaller than 7, so that we require at least 7 characters for security reasons. If any of these conditions is met, so if we have invalid data, then I want to return to not continue with function execution, and I'll send back a response with a 422 status code and some extra information, like a message where I say invalid input password should also be at least 7 characters long. Something like this. That's the response we sent back if we got invalid input. If we make it past this if check though, we know that we have valid input, and then we want to store our user data in the database, so in that user's collection. Hence here we want to insert a new document. We can do this with insert one as we saw before in the course. And we can create that document on the fly here and simply add the email field, which is that extracted email we got here, and then the password. However, regarding the password, there is something we have to keep in mind and take care of. We should not store the plain password like this in the database. Because if our database ever gets compromised by some employee or a third-party intruder, then all our user credentials would be usable just like this. Hence, for security reasons, it is a best practice and strongly recommended that you don't store plain passwords in the database, but that you instead encrypt them such that they can't be decrypted. And we will still be able to verify them later, no worries, but we want to make sure that we store passwords in encrypted form. And to encrypt passwords, we can install another third-party package with npm install, and that's bcrypt.js, like this. That's a package which helps us encrypt passwords, or encrypt any kind of data, of course, but we'll use it for a password here. And hence I'll start my dev server again, and now I want to encrypt my password, and for this in the lib folder, I'll add another folder, auth.js, which will hold those authentication related utility methods. And here I want to import from bcrypt.js, from that package we just installed. And from there, I want to import the hash function. Then I want to export an async function called hash password and take the original plain text password as an input. And then in there, call hash on that password. And the second argument then should be a number of salting rounds, which in the end will influence how strong that password is. And here a value of 12 is considered to be safe. The higher the number, the longer this function will take. The lower the number, the more insecure it is. So 12 should be an okay value. And hash will then also return a promise, which eventually gives us that encrypted password. So we can await this to have our hashed password here in the end. And then it's this hashed password which I return, just like this. Now back in signup.js, we therefore now want to create such a hashed password and store that in our collection instead of the plain password. So here I get the hashed password by calling hash password and importing that function from the lib folder and the auth file there. And then to hash password, we pass our plain text password. And then it's this hashed password which we store in the document, so in the collection overall. Now insert1 also returns a promise, so we can await this. And this will return the result of this operation, which then, for example, gives us access to the automatically generated user ID. Now with that, we're storing a user in the database. And now I want to send back a response, therefore, a success response, where we say something like created user. Now I'll not implement error handling here, since I really want to focus on the core auth parts, and we saw error handling with MongoDB and so on in action before already, and hence I'll keep this lean and focused on the parts that are related to user creation in this case. And therefore now we should be able to test this. In the next lecture, let's make sure that we send a request to this signup API route. Now with the signup API route added, let's go back to the auth form and make sure that we talk to this API route when the user authenticates. For this, in the end, we want to listen to the form submission, and then if we are not in login mode, which means we are in create mode, then we want to send a request to our backend here to create a new user. For this, I'll add a new function, the submit handler, let's say, where we get that event, which we use to, again, prevent the default, as we did it many times before in this course. And then here, I'll first of all check if we are in login mode, which means we want to log user in. We want to log a user in. That's something we can't do yet, so I'll do nothing here. But if we are in the not login mode, so in the create mode, then we want to send a request that creates a new user. For this, I'll create a new function outside of the component function. We could also create it in a brand new file. I'll just do it here to keep the component function lean. And I'll name this function create user, like this. And here I expect to get the email and the password. we will need to retrieve that from the forum in a second. And then here I want to send a request. So again, we can use the fetch function as we did multiple times before in the course and send the request to /API/auth/signup to target this signup API route. Now it should be a post request, so I'll add this second argument here and set the method to post and then add the body. And the body will be in JSON format, and I'll add an object with email and password, so with that data we get as parameters. Then let's also add some headers to pass extra information about the fact that we're sending JSON data by adding that content type header like this, and we configured this request. Now I will turn create user into an async function so that again we can use a wait here, and of course then we can wait for our response and then handle that response. Now, for example, by getting the data out of that response with response JSON and awaiting that, since that also returns a promise. And then maybe check if not response okay. So if it's not okay, if we got an error status code, and then we could throw a new error where we use data message as a message, or if we don't have that, just say something went wrong. And then ultimately, I'll return data here though, if we make it past this if check. So that's create user. Now here in that else case in the submit handler, we want to call create user and pass in the email and password. Now for this, we need to get access to the entered email and password, and we can use state with two-way binding for that. We did that in the blog project, for example, or we use refs for quick and easy access. And I'll do the latter. I'll import use ref from React like this. And then in the component function, just create two refs for the two inputs we have. And we have the email input ref then. And we also have the password input ref like this then. Now we just need to wire them up. So on the email input, we set ref equal to email input ref. And on the password input, we set that equal to password input ref. Now that we got those refs, we can get the data in the submit handler. So here we got the entered email by accessing the email input ref.current.value as you saw before in the course, and get the entered password by accessing password input ref.current.value. Now we could add validation here. That's optional. We definitely need validation in the API route though, because that validation here on the client can always be tricked. And we do have validation on the API route, so I will save some time here and save some code and not add validation in this component. So we'll skip this here, and instead we'll use that data just like this, and then create a user here. So for this, we pass the entered email as a first argument to create user, and the entered password as a second argument. Now, of course, create user is an async function, and hence returns a promise, so we can also turn submit handler into an async function, so that we can use await in here as well, and await that response, that result of that operation. Maybe also wrap it with try catch to catch any errors we might be facing here. And then we can handle these errors. And for the moment, I'll just console log any errors we might be getting, like this. And if we are successful though, if we stay in that try block, then we of course know that now a user was created. So then here I'll just console log the regular result for the moment. And we can give the user a better feedback, but we did dive into those things before in the course already. And therefore here I really want to focus on the authentication exclusive part. Hence here for the moment, we will just log the result to the console and not do anything else. Now that should be sending a request. Of course, we now still need to connect the foreign though. So we connect on submit to the submit handler like this. And there also is something we still need to do on the API route. Because I'm sending a post request here, and indeed only post requests should trigger this user creation. So here in this async function handler, I actually want to check if request method is equal to post and only continue in that case. So if request method is post, then I will execute that code. Otherwise, I don't do anything. Of course, therefore, alternatively, if I revert this, we could also check if the request method is not post and then just return and only continue if it is post. Then we don't need to wrap everything with that if check. We could have done that before in the course as well, in similar cases. Okay, so now if we save everything, this should work. If we go back to the auth form, reload and click on create new account, and I open the developer tools to check for output and errors. If I enter some data here, let's say a password which is too short, then I get back a 422 response with my error message that the password is too short. And of course, we might want to show that to the user, but for the reasons mentioned a couple of seconds ago, I'm not doing this here. So if I now enter a password which is long enough and I send this request, that looks better, and I get created user as a response. And if we have a look into our MongoDB collections here, we have the auth demo database, and in users, we see our user data, and we see that password actually is an object, though. That's not entirely correct. I'll have to look into that again. That should not be an object. It should be a super long, strange-looking string. But generally, it's working. If you are getting some error with your connection to MongoDB or something like this, double check that you also whitelisted your local IP under network access, by the way. But with that, let's have a look at our password generation and what's going wrong there. In the API route, I'm creating that hashed password, and yes, that of course returns a promise. I forgot to await that, and hence I stored the promise in the database instead of the result of that promise, which would be that string, and hence we need to await hash password here. If we do that, and I then send that same request again for the same user, now if we update MongoDB, we see that here that's our hashed password. So that's looking good. Let me delete the other user. And that's how we can create users, totally on our own with the tools we learned about before in the course already. Now, creating users works, but at the moment we can create the same user with the same email address multiple times. And that's typically not what we want to do. Therefore, to avoid that we do that, in our signup handler function here, we should check if a user for a given email already exists. So once we connected here to the database, before we hash the password and store the user, I want to check if a user already exists. I want to get an existing user by using db collection users and calling find there, or find one to be precise. Find one allows us to find one document. And we pass an object to find one where we describe how to search for that document. Key value pairs here. And the keys are the keys we have in our documents. So email, password, or underscore ID. And we can then search for email. And the values are the values we want to search for in the database. So in this case, I want to search for documents which already have the email we're getting here stored in the email field. Now we should await this because that returns a promise. And then it's either undefined if we did not find a user for that email, or it is the user object. So if it is not undefined, if it's truthy, So if it is an object with that user data, then we know that the user already exists. So that's then when I want to return so that we don't execute the other code. And I want to send back a different response. A response with a status of still 422 maybe, and some data where I have a message where I say user exists already or something like this. Now, one thing we also want to do here, which I haven't done before, is close our database connection. We should always do that. So we should use that client and call close once we're done. Here and also here at the bottom, of course. We want to do that. But now with those changes made, we should not be able to create the same user more than once. If I try to send this request or the already existing email address again, I get a 422 error with the user exists already message. If I use a different email address, which does not exist yet, it should work though. And it does. And in the database, if we refresh it, we indeed see that every email address exists only once. So that's now also working as it should. Now that we are able to create users, it's now time to work on the authentication functionality. So on logging users in and getting that permission, this token for our logged in users, and being able to find out if a user is logged in, both on the client side for changing what we see and for disabling certain routes, as well as on the server side in different API routes we might be adding. And that's now the part where this next auth package, which we installed earlier already, becomes important. It helps us with authenticating users, and it helps us with finding out whether a user has that permission by managing that token creation and storage, both parts, behind the scenes. Now, to use NextAuth, we start by adding another API route. Because logging a user in, signing a user in, that of course also requires a request to be sent to a certain API route, where we then look into the database and find out whether we have that user in the database and whether the password is correct. And therefore, I'll create another file in that API/auth folder, but this file now needs a special name. It's a square bracket file name, so a dynamic API route, and it's a dynamic catch-all API route, which catches all unknown routes that start with API/auth. Here we can then use ... nextauth, written like this, one word. And in here, we now use that nextauth package. And we need this catch-all route because the nextauth package behind the scenes will expose multiple routes for a user login and for a user log out, for example, a couple of other routes as well. And in order to set up its own routes and handle its own routes, we need to have a catch-all route so that all those special requests to these special routes are automatically handled by the nextauth package. We can still also define our own routes, like the signup route in addition, as long as we don't overwrite one of the built-in routes nextauth exposes. If you want to find out which routes it creates, you can check out the official nextauth documentation and click on REST API there. And these are the different routes. They all start with /API/auth, as you can tell, which will be handled by NextAuth, so we shouldn't clash with those. Now, how do we then use NextAuth here? We first of all import it in this square bracket nextauth.js file. We import NextAuth from NextAuth. And then with this imported, we export NextAuth as a default, but not like this, but we execute it. So NextAuth here is a function which we can execute. And when we execute it, it returns a new function, a handler function. It needs to, because this is still an API route. And therefore, an API route still needs to return a function. It needs to export a function. but that exported handler function is created by nextAuth, by calling nextAuth. And when we call nextAuth, we can pass a configuration object to it. That's an object which allows us to configure nextAuth's behavior. And you can dive into the official docs, configuration options to learn about all the options you can and must set here. Now, in our case, we want to set the providers option here and set this to an array. And here we need to import something else. We need to import providers from next-auth/providers like this. And then here in the providers array, we use providers dot. And then here you can choose from the long list of supported providers. And again, check out the providers docs to learn more about the concrete way of setting up the different providers. But here we need the credentials provider, which means that we bring our own credentials. Now this takes a configuration object itself. And here we now can configure a couple of things. For example, we can set the credentials key and then here define what our credentials are, email and password. We could use that to let nextAuth generate a login form for us. Here, however, I don't want to let nextAuth generate a forum for me. I already have one, and hence I'll not set credentials. The only thing we need to set here actually is authorize. And authorize turns out to be a method. It's a method which Next.js will call for us when it receives an incoming login request. At the moment, we're not sending such requests yet, but we will soon do so. Authorize is an async function, so it returns a promise, and as an argument, we get the credentials that were submitted. And that is an object with the data we submitted, for example, email, password. In here, we now have to bring our own authorization logic, check if the credentials are valid, and tell the user if that's not the case. For example, throw an error if that's not the case. Therefore, in here, we again want to connect to the database, and hence import connect to database from the lib folder, and get hold of that client here by awaiting this. We also want to close the client later, of course. So let's already do that so that we don't forget it. And then we want to find out if we have a user for the entered email and if we have a user with that password then. So if that password is correct. Hence, let's first of all check if we have a user. For that, I'll have my users collection, which I get access to with client.db.collection users. Let's do that in one go. And then we can use the users collection to find one user where the email is equal to credentials.email. And I'm expecting that credentials will have an email property. I can expect this because it will be us who later set those credentials when we send a request from the client-side code. So I expect to have an email field in the credentials object, and then I check if I find a user with that email. We should await this because it's a asynchronous task, returning a promise, and then here we got our user. Now, if we don't find a user, if not user, then we know that there is no user with that email address. In that case, we can throw a new error where we say no user found or anything like that. Now, when you throw an error inside of authorize, authorize will reject that promise which it generates, and it will then by default redirect the client to another page. But we will be able to override this so that we stay on this login page and maybe just show an error there. But that's something we'll do later. So here we throw an error. But if we make it past this if check, we know that we found a user for the email address. That's nice, but we now also need to find out whether the password is correct. Now keep in mind that we hashed the password, so we will not be able to just compare the submitted password with the stored password. The stored password will never be equal because it's hashed. Now we can't unhash the password, but we can hash the incoming password again to find out if it's equal. But if we just call hash password again, we would also generate a different hash because it's not always the same. But bcrypt.js has a method that helps us. It has the compare function. And that allows us to find out if a plain text password matches a hashed password. So if that plain text password could result in the same hashed password. And if that's the case, we know that the passwords are equal. For this, we here export another async function. Verify password could be the function name. And here we then get the plain text password and the hashed password. So both passwords. And then we run compare. And there we pass in the plain text password and the hashed password. And await this because compare does return a promise. And that will return a boolean, which is true if the passwords are equal and false otherwise. And hence here I'll return that boolean. Then back in our authorize function, we can run verify password and pass in credentials.password, which is the submitted password with which the user tries to log in. And as a second argument, the password stored in the database, so in that user object. So we pass in user.password as a second argument, accessing that password field which is stored in MongoDB. We need to await this because verify password is an async function and hence returns a promise. And then we got our isValid result here. Now, if this is not valid, if the password is not valid, then again, we want to throw an error. We could say, could not log you in, something like this. If we make it past this if check as well, we know that we have a user for the given email address and that the password is valid. So in that case, the user is logged in, and in that case, here we should return an object. If we return an object instead of authorize, we let Next.auth know that authorization succeeded, so that the user is logged in. And this object will then actually be encoded into that JSON web token. Hence here we could, for example, include the user email. We should not pass the entire user object because we don't want to include the password. Even though it's hashed, we don't want to expose that to the client. So that's the object we return, and that will then be encoded in a JSON web token. But speaking of that, to make sure that a JSON web token is created, we should go to the Next.auth config object, and besides setting up our providers, also add the sessions option here. That's another option which you can set up here. Actually, it's session, not sessions. It's an object where you can configure how that session for an authenticated user will be managed, and there you got a JWT key which should be set to true, so that JSON web tokens are being used. For some other authentication providers, you have other ways of managing this, for example, that a session is stored in a database, but for credential-based authentication, for this provider, you must use JWT and set this to true. As you see, it would be set to true automatically if you don't specify a database, and we aren't specifying a database because we handle all database access manually anyways with this specific provider, but nonetheless, setting it to true explicitly also isn't too bad. Now, if you do use other providers, then you might of course be able to add a database and use a session. It really depends on which authentication provider you use. For example, if you use the email authentication provider, where you get an email with a magic link sent to you, then you need to add a database in which the emails will be stored, and you don't need to use JWT. But that's just a side note. Here we are using JWT, we are using credentials, and hence we need to configure it like this. Now, before using this API route though. Before sending requests, there's one thing I want to do. Client close, of course, should be called before we return, and also should be called if we throw an error, so that we still close that database connection. That is something we should do here. And actually, I just saw this should be hashed password, of course, not hash password. So that's one thing. That's now the backend. That's the authentication API route using Next.auth. Let's now find out what we do on the front end, on the client, to log users in. At the moment, we only have the API route for logging users in. We also need the front-end logic in the auth form component. There, we have this check whether we are logging in, but we're not doing anything if we are. Well, here we need to sign the user in. And here we now don't need to send our own HTTP request. We don't need to configure it ourselves. And we shouldn't. Instead, here we'll again import from Next-auth, but now from Next-auth/client. And from there, we can import the sign-in function. This sign-in function. That's a function which we can call in our component to send a sign-in request. And the request will be sent automatically. So we just call sign-in here, and now we can pass in some data here. The first argument describes the provider with which we want to sign in, because we could have multiple providers in the same application. Here it's the credentials provider, and hence we should write it like this. Then we can also pass a second argument here. That is a configuration object now, where we can configure how the sign-in process should work. And specifically here, we can add a redirect field and set this to false. You might remember that I said that when Next.auth is used here on the backend, in this API route, that when we throw an error here, because authentication failed, that by default, Next.js would redirect us to another page, to an error page. And that is something we could utilize. We can then set up such an error page, and we can configure that error page. You can check out the next options for the credentials provider to learn more about that. But more often, you typically want to leave the user on the page where he or she is and just show some error message there. So if we are logging in here, I don't want to be redirected if it fails. I maybe just want to show an overlay or a little text here below the inputs. And to avoid that we are redirected, we can set redirect to false in that second argument of the sign-in method, so in this configuration object. Now, when setting redirect to false, sign-in will actually return a promise, which eventually yields us a result. The promise will always resolve. It will not be rejected, even if we have an error in our backend authentication code. But if we had an error there, result would be an object that contains information about the error. If we have no error during authentication, result is still an object, but without the error information. So this will never throw an error, it will never be rejected, it's just the content of this result object which will differ. And now, besides passing redirect false, we also want to pass our credential data to the backend. We do this in this second argument as well, because it is actually the second argument as a whole, which is received in our authorize function as this credentials argument here. So this credentials parameter is that second argument, which we pass to sign in. And here I'm trying to access an email and a password field, and therefore to make sure that this works in auth form, besides setting redirect to false, we should also add in the email and set this to entered email, and add a password key and set this to entered password. And with that, we're sending this sign-in request, and I'll now just log that result here. And that's all we have to do when it comes to signing users in. If we now save everything, we go back to that login page and reload it. If I enter a valid email here, but an invalid password and I click login, I get could not log you in. Which makes sense because that proves that we made it past this first check where we check for the general existence of a user, but we then failed when we tried to get the password. And you see what I meant? We didn't get an error here. Instead, we just have the result object, which has an error value. Now, if I do enter an invalid email address, which is not part of the database, I get no user found. Now, if I do enter valid credentials though, then we see that error now is null. So now we got no error, instead we succeeded. And that is how we can sign a user in. Now we can create users and log them in. And we get this yes/no response. What we're not doing yet though is working with that token. Because of course, in the front end, in our front end components, when we get the result here, we could now check if result error is falsy, which means we have no error, which means we succeeded. And we could then set some auth state, maybe also with help of React context or Redux, and use that state to change what we see. For example, to change the options in our header. We could now do that. But whenever we reload, that state would be lost because we start a brand new single page application when we reload. All the state, which was only stored in memory from the last visit, would be lost. And that's not what we want. That's also not what we have to accept, because that's exactly why we have this token concept. We can store that token in some more permanent storage than just our memory. And we can then also use that token to send requests to potentially protected APIs, like the Change Password API, which we haven't implemented yet. And therefore, in the next lecture, let's now see how Next.js helps us find out whether a user is authenticated or not, starting on the client, later also for the API routes. So let's start on the front end, and let's start utilizing the answer to the question whether a user is authenticated or not there. For example, I want to make sure that the options in the header change based on whether we are authenticated or not. And again, Next.js makes that pretty easy for us. It is worth noting that after we logged in successfully, Next.js added a cookie. We can see this in the browser DevTools if we go to Application, Cookies, and select our domain. Here we see some cookies that were set, and these are cookies which are generated and managed by Next.js. For example, this session token is this JSON web token in the end. That was set automatically by Next.js when we logged in successfully. And it will also use that token automatically for us when we try to change what we see on the screen or when we try to send requests to protected resources. For example, we can get the answer to whether the user is logged in or not by finding out whether such a valid token exists. And we could come up with some code that allows us to do that manually, though that code would involve that we need to send that cookie to the server and let the server decide whether it's valid or not. And hence, it's good that we don't have to do that. Instead, if we want to find out if the user using this page at the moment is authenticated or not, Next.js gives us a convenient way of doing that. Let's say in our components, in the main navigation component, here I want to show profile only if the user is authenticated. Since we use NextAuth, all we have to do for that is we have to import something from NextAuth client, and that something now is the use session hook, which we can use in any functional React component. Here we can now call use session, and use session will return an array with exactly 2 elements. It is an array where the first element is the session object describing the active session, and the second element is loading, which tells us whether Next.js is currently still figuring out whether we are logged in or not. And for the moment, I'll just log both. I'll log loading and I will log session. If we do that and save this and go back to the browser, to the console and reload, we see true and undefined and true and some object and false in some object. The first log is always the loading state. So you see initially we're loading, we are finding out whether the user is authenticated or not, and hence we got no session object yet. Then at some point we're still loading, but we actually do have that object yet, and hence then loading is false and we have that object still. And in that session object, we got that user data, which we encoded into our token. And we got some expiration date, which tells us when that session will expire automatically. Though it is worth noting that this session will be prolonged automatically if the user is active. So now that we know what's in there, what we can do is we can change what we see based on these two pieces of information. And we can make sure that the profile link is only showing up if we have a session. So not if we're still finding it out, and also not if we found it out, but the answer is no. Only if we have a session, then we show this information in our header. So if I save this and reload, you see that profile flashes briefly because it's only loaded after a very short time duration once we found out that we do have a session, to be precise. Now that flashing could be unpleasant here, and I'll come back to how we can optimize all of that later in this section. But that generally is how we can find out whether we are authenticated or not. Now we can utilize this to then, for example, only show the login link if we don't have a session. Only if we don't have a session, we want to show the login link. I actually also don't want to show it whilst we're still loading though. So I want to show it only if we don't have a session and we're not loading. So if we're not loading and we then know that we have no session, then I want to show the login link. For the log out button, I only want to show that if we do have a session, because logging out only makes sense if we are logged in. With that out of the way, you see the login link is now gone. Now I am still on the login page because I can still visit that page. I'll show how we can prevent this later as well, but we now at least know how we can control what we see on the user interface. And that is an important first step. Now, before we dive deeper into route protection and how we can control which pages can be visited and how we can optimize all of that, let's first of all explore how we can log out so that we can also go back to log out state.